Well, welcome everyone. I'm Mike Shanahan, the Planetarium Director at Liberty Science Center's Jennifer Chalsty Planetarium. I'd like to welcome those of you from the Montclair State University Alumni 2020 Homecoming Group. And this is our tour of the late October, early November skies, using the same software that we use in our main planetarium to show the nighttime sky. We have a great gathering of the planets throughout the rest of the year 2020. We'll be talking about that, and also some of the unusual constellations and other objects you can see in the sky here this time of year. So let's go ahead to the nighttime sky, which is where all of astronomy has its origins. So here's a sky you'd actually see in late October until the 1st of November. We're still on daylight saving time, so it still gets dark kind of late. We're going to go till about 7 o'clock or so, looking over towards the western skies to have a look at, first of all, what's there to be seen in the west as we head towards the evening. We had a first quarter moon back on the 24th of October. The moon, as we'll talk about later, will be a full moon on Halloween. So looking towards the western sky, here we can see the constellation of Sagittarius still. That's a classic summer constellation, and you get one final chance to catch it at sunset here in late October and early November. If you imagine it as a centaur firing an arrow, Sagittarius actually means archer. Here is the bow, there is the arrow, and here's his elbow pulling back the bow. So that may be hard to see. We'll show you a picture of that in a moment. You could also imagine it as a teapot, with this being the teapot handle, the top, and the spout. So a couple of different ways to view that. If you see a teapot, try to find that. The connected dot may not be very helpful, but here's our picture for the archer, Sagittarius the archer, or you can again think of it as a teapot. That's a more modern term. They didn't have tea, as far as I know, in ancient Greece. What you're going to really notice, though, over in the western sky right now is the blazing dot of the planet Jupiter, minus 2.5 magnitude. It outshines every star in the sky. And even in a moderate telescope, the planet Jupiter shows interesting banding, and you can also spot its 4 big moons. These Galilean moons were discovered by Galileo with his newfangled telescope in the year 1610. And they go around Jupiter so fast that the arrangement is different every night. By the way, now's a great time to get a telescope if you want to do some planet hunting this autumn. So Jupiter is enormous. Here's the planet Earth in comparison. It would take about 11 planet Earths just to go across the diameter of Jupiter, or 1,300 Earths to fill the entire giant planet. It's often called a failed star. If it had much more mass around Jupiter, it would have had enough pressure in the core for fusion to begin, and we'd be in a 2-star system if that were the case, instead of just having 1 star and 1 big planet. You can see the red spot, a hurricane that's been raging at least for hundreds of years. And coming into view, we also have Juno, that's spelled Juno, the mission that's currently at Jupiter. Arrived here in 2011. It's going to be functional for at least another 10 months or so. And every 53 days, it gets really close to Jupiter, and we get great close-up images with every one of what's called a perijove, which just means a close encounter with Jupiter. Then it goes millions of miles away and then comes again and again for another perijove. The next close flyby of Jupiter by Juno will be the 8th of November. So that is Jupiter, and it's in our skies very close to the planet Saturn. Saturn not as bright as Jupiter, but in a telescope, it's an absolute knockout. Those beautiful rings that at no point touch the planet Saturn. Discovered in the 1650s by Christian Huygens, Galileo's telescope, not quite good enough to ever evolve to resolve the rings of Saturn. Now, we don't have a mission at Saturn right now, but the Cassini mission was there from 2004 to 2017, showing us the planet close up. Now here, for size comparison, we're now comparing the Earth to Saturn. Saturn, not quite as big as Jupiter, but easily the second biggest planet. Also has fascinating storm patterns here. This storm at the North Pole has a hexagonal shape. Scientists are doing experiments in the labs right now here on Earth to try to figure out what combination of cloud or fluid dynamics would give you a six-sided storm pattern, as we have here at the North Pole of Saturn. The rings, of course, are the most identifiable feature of Saturn. They look like they're solid from a distance, but as we get close, we'll see they're made of little bits of ice and rock, mainly of ice, as small as a pebble and as large as a school bus. And some of the interesting gaps in the rings are carved out by actual moons embedded in the ring. So here we have Pan coming into view. It's a moon about the size of Manhattan Island that has carved out a nice little niche for itself in the rings of Saturn. Currently, Saturn is number one in terms of the moon count. There are 82 known moons around Saturn compared to the 79 known moons around Jupiter. So the rings of Saturn also will not be there forever. Eventually this matter will fall into Saturn. So we only have about 200 million more years. So enjoy the rings while we have them. Now if you look towards the sky again, here again is the sky you would have seen on October 24. Here again we have Sagittarius, the centaur or the teapot. Now Sagittarius was named by the Greeks, Romans, or Babylonians 2,500 years ago. And it's kind of amazing we can still use names invented for the constellations that long ago. The stars are incredibly far away. And although they're all moving, it takes a long, long time to tell their motion. They're like cars on a very distant freeway. It takes a while to even tell they're moving. So this star here will not go this way tomorrow, and that star is not going to go that way. The planets, on the other hand, are like the cars going right in front of your house. You can see their motion pretty handily. They are so much closer than the stars that we can see Jupiter and Saturn move against the starry background. Not in the course of one night, but if you observe over even a week, you can tell that the planets are moving. The very word planet comes from planetes, which means wanderer in Greek. So we're going to do a little time lapse, and we'll see how Jupiter and Saturn will change their position between now and the end of 2020 as time goes on. If you make a little time-lapse movie out of the behavior, every time the moon goes by, we've gone by another month. And as we go into November, we will clearly see that Jupiter and Saturn are drawing closer to each other. And in fact, they'll be in a very close gathering or conjunction by the end of December, right before we lose them entirely in the light of the setting sun. So here's a view we'd see on the first day of winter. So here's a view again that you'd see now, but if we go to November, you'll see already that Jupiter and Saturn will be closer to each other, but will still be clearly visible low in the southwestern sky. So that is November 24. If we go to December, they'll be again so close they'll seem almost fused together into a single brilliant dot of light. So here's a view on Christmas Day. You can barely see that Saturn is there to the lower right of the brighter Jupiter. And that'll be just about a last hurrah. The last chance we'll get to see these two before they plunge into the light of the sun will be on the 1st of January 2021. They'll be right down there, just appearing briefly before they set. So that is the view towards the western sky, but now let's turn around and look towards the northern sky. As we come around to the north, you should be able to catch the famous Big Dipper pattern in the sky. The Big Dipper is a North American term. It goes back a couple of hundred years. And it's very convenient in part because it points the road to the North Star. The North Star stays in place and marks off the direction north. It's a very handy guide for finding a location, but it's not that bright. So it's nice to have a guide like the Big Dipper to show you the road. The North Star actually belongs to the Little Dipper, kind of the smaller cousin of the Big Dipper. The official names of these two constellations are Ursa Major, that's Big Bear, and Ursa Minor, Little Bear. And in fact, astronomers now agree upon 88 official constellations, mainly derived from the Greeks and Romans, that now serve as a roadmap to the sky, to serve as a reference for where various sky events occur. If we go through the night as the world keeps on turning, we'll see an interesting phenomenon. We're pointing out Cassiopeia. We'll hear about her momentarily. But it's on the far side of the North Star from the Big Dipper. And a thing to note that as the night goes on here, as we go later into the evening here in October, the Dipper gets very low in the sky. It never goes away from New Jersey, but it gets very low. And consequently, Cassiopeia gets quite high in the sky. And if you have the Big Dipper blocked by buildings or trees or whatever, you can use Cassiopeia, which now resembles an M. The middle three stars can be seen as an arrow that just kind of roughly point you to where to find the North Star. You only have to get close because the North Star is the only even sort of bright star in its part of the sky. So the reason why the North Star stays in place is that it's over the North Pole, the axis of the Earth's rotation. So as the world spins, it stays there, marking off north, while all the rest of the heavens appear to pivot around it. We're lucky to have it. They have no equivalent south star down below the equator. Now, looking towards the eastern sky, we have some classic constellations of the fall. The fall constellations are not as bright as the winter ones that we'll see at the end of our program, but they do connect very nicely into a story that you may know if you know your Ovid, or if you've seen the movie Clash of the Titans. So this begins with the constellation of Cassiopeia. She was the queen of Ethiopia, married to Cepheus, who was right next to her. Cassiopeia bragged about her beauty to the sea nymphs, and they complained to Dad, who happened to be Poseidon, the god of the sea. And being the god of the sea, he made a sea monster to attack the land of Cassiopeia. Now, in our outline version, it looks like a friendly whale. And in fact, Cetus shares the root with the term cetology, the scientific study of whales and dolphins. But in our story, it's not a friendly whale. It's a ferocious sea creature, sea monster, that comes and attacks the land of Ethiopia. So Cassiopeia and Cepheus go to the oracle in Delphi. That's what you did when you had a problem back in these ancient times, to ask how to call off the sea monster. And the oracle said there's kind of good news and bad news. Good news is there is a way to stop the beast. The bad news is they have to sacrifice their daughter, Andromeda. Now, Andromeda is one bright strand of stars and one fainter line. And also, oddly enough, it shares its one star, the head of Andromeda, is also part of the great square of Pegasus the flying horse. So poor Andromeda doesn't do too well in the stick figure competition. Hard to believe that this represents the maiden so lovely that Perseus, as we'll hear in a moment, fell in love the instant that he looked at her. But there she is, shackled to a rock by the sea. Things are looking kind of dire, when in fact the aforementioned Perseus comes across the situation and is able to stop the sea monster. So Perseus is down here at the feet of Andromeda. You have kind of just a little squiggle of stars. So he, like Andromeda, doesn't do that well in the stick figure beauty contest. But he was a great hero and sent on a very dangerous mission to find and slay the Medusa. So Medusa had snakes for hair and a gaze that could turn you to stone. But fortunately, Perseus literally had friends in high places. So the goddess Athena gave him a shiny shield and the advice to gaze at the reflection of Medusa in the shield and avoid her gaze directly. That was a way to avoid being turned to stone. And then Mercury, the messenger, gave him a bag full of cool gadgets that included winged sandals that would allow Perseus to fly. So he flies off, encounters Medusa, does chop off her head by looking at her reflection in his shield. Oddly, that mix of blood of the Medusa and salt water of the Mediterranean created Pegasus the flying horse, but he has only a walk-on role in our story. Perseus had winged sandals. He didn't need a flying horse. So as Perseus wings it home to Greece, he flies over Ethiopia, and sees Andromeda about to be attacked by the sea monster. So a lot of my career, both working in Hawaii and working with native stories in various circumstances, you always wonder about how authentic some of these stories are. But here is a vase from 2,500 years ago from ancient Greece that actually depicts the story we're telling you. So here is Andromeda shackled to a rock. Here is Cetus the monster looking more like a boar. And here is Perseus with his winged sandals. And most importantly, here is his bag full of cool gadgets, which now contains the head of Medusa. So he looks down, sees Andromeda, falls in love right away, zips down and holds up the head of Medusa, which even in death has the power to turn to stone. So the monster is turned to stone, petrified, which is what petrified means, and then Perseus and Andromeda marry and live happily for many years. So the story is based on the Metamorphosis of Ovid from the 2nd century AD, but you may know it from the movie Clash of the Titans, which tells the story in a very dramatic way. Came out in 2010. They changed the name of the monster from Cetus to the Kraken, which gives the movie its most famous line, "Release the Kraken." So that's the 2010 remake. The original version from 1981 is also very nicely done and was the last movie that featured the work of the great stop-motion special effects wizard Ray Harryhausen. So that's all on parade here. Maybe connecting these stories, constellations by a story, was a way to remember their positions, as it were. And it's also a rich part of the sky for deep sky objects. So in Andromeda, we have what was called the Andromeda Nebula until about 100 years ago. At first we thought it was a cloud of gas in our own galaxy, the Milky Way. We now know nowadays that it's a whole separate galaxy, and in fact much larger than our Milky Way. So Andromeda here is about 1 trillion stars. Our own galaxy, the Milky Way, is about 1/4 of that, about 250 billion stars. And even though most of the universe is expanding away from everything else in the universe, really heavy things, like say galaxies, are attracted to each other. And eventually, in about 3.5 billion years, Andromeda and the Milky Way are going to run into each other. And eventually, after more than one pass, they'll settle down into a single new galaxy that'll be larger than the two parent galaxies. Now we know nowadays, as we didn't 100 years ago, that the universe is full of galaxies. Every splotch you see in the background is a galaxy. We know now there's probably as many galaxies as there are stars in Andromeda, at least 1 trillion galaxies out there. And for our two galaxies, we're going to totally reduce the galaxy count by 1, as our two galaxies in 3.5 billion years will forge into a single non-whirlpool-y sort of round or oval galaxy. We have some time, but we're taking names now for the name of our new galaxy so far. Leading the competition is the Milk-Dromeda galaxy, as a new term for our galaxy. So we'll be talking in a moment about how we even figured out that this little fuzzy patch that you see in the sky called Andromeda is actually a whole separate galaxy. But first of all, let's go back to Perseus. It's got some interesting stuff as well. So this bright star in the knee of Perseus is actually supposed to be the eye of Medusa blinking at you through the bag that Perseus put the head in. And that's because this star, which is called Algol, is a star that winks. Every 3 days it drops in brightness by a factor of 3. It gets 3 times dimmer than it normally is in a very steady, repeatable manner. And that was odd enough to our ancestors that they identified it with being the demon star and being the winking eye of Medusa. It would go from a nice 2 magnitude down to 3.4, or 3 times dimmer than it normally is. Well, it's not really mysterious. We know nowadays what's going on. You just have 2 stars that are orbiting around each other, and as they orbit, when the one star goes behind the other, the brightness drops off by a factor of 3. And it happens on a very regular basis. It happens every 2.86 days and takes a total of 9 hours each time for the dimming, then back to full brightness again. So there are many ways in which stars can vary in their brightness. In this case, it's by being eclipsed. But right next door, in the constellation of Cepheus, the king of Ethiopia. There's another kind of variable star that became the means by which we discovered how far away the Andromeda Galaxy is. It's called a Cepheid variable named for this constellation, and these were studied in depth by Henrietta Leavitt, a researcher at Harvard University in the early 20th century. And these are stars that are very unstable as they approach the end of their life. And they vary not because they're being eclipsed by another star, but because as they grow unstable, they'll swell up and get really bright. But then as they swell up and get bigger, the pressure in their center is reduced, and it causes the star to collapse down again, causing it to become dimmer. But as it begins the process of collapsing down, as we'll see in a moment, by collapsing down, the pressure builds up again in the core, and that causes the star to swell up again. And then in her research, Henrietta Leavitt discovered that the longer this cycle took, the brighter the star was intrinsically. So a star that took 100 days to do one full cycle was intrinsically brighter than a Cepheid variable that took 2 days to go through its full cycle. So a lot of astronomy is building upon the work of those who have come before you, what Sir Isaac Newton called standing on the shoulders of giants. So this knowledge was established by Henrietta Leavitt at Harvard around the year 1900. So in 1923, Edwin Hubble moved to then fabulously clear-skied Los Angeles to use the new Mount Wilson Observatory there to observe what was called then the Andromeda Nebula, thought to be a nebula, a cloud of gas in our own galaxy, maybe 1,000 light years away. Well, in studying Andromeda in his new telescope, Hubble discovered a Cepheid variable in Andromeda. This black and white picture shows you where he found it. Probably hard to see, but these two lines here, in the middle of the two lines is where the star was. He marked it originally N, thinking he had discovered a nova, but then came to realize it wasn't a nova, it was a variable. So he wrote VAR exclamation point. He had discovered a Cepheid variable in Andromeda. And because he knew based on Leavitt's work that a long cycle variable like this had to be intrinsically very, very bright, when you know how bright something is, you can figure out how far away it is, and he came to realize this was not in our own galaxy. It was millions of light years away. In fact, we know now the Andromeda Galaxy is about 2.5 million light years from us. Even going at 186,000 miles a second, it takes light that long, 2.5 million years, to go from Andromeda to our telescopes. So it's been called the day the universe changed. The observation was made on 6 October 1923 and announced to the world on the first day of 1925. All of a sudden, our galaxy was not alone in the universe. We know now there's probably as many galaxies as stars in the Andromeda Galaxy. So we also have the planet Mars in the sky. Mars is going to be with us and blazingly bright for November. Mars changes in brightness like no other planet. It's sort of a variable, but a planet variable instead of a star variable, a variable star. That's because Mars is small. It's a small reflector of light. So when it's far away, like it was a year ago, 230 million miles from us, it's quite faint, like no brighter than a star in the Big Dipper. But as time goes on, Earth on the inside track, being nearer the sun, catches up with Mars. And throughout the year 2020, this tumultuous year of 2020, Mars has gotten brighter and brighter and brighter until it winds up being blazingly bright here in October and early November, outshining any star in the sky at around minus 2.4 magnitude. So that is why Mars is flaring up in brightness and will in fact be bright for November and will then drop off pretty dramatically from then, although we'll have Mars with us all the way until July of next year. We also have a moon that was the first quarter moon back on the 24th of October when we did the program live for the Montclair State University alumni group. But it's going to be a full moon on October 31, the first full moon on Halloween in 19 years. 2001 was our last Halloween full moon. We think of full moons being Halloweeny, but If you get a full moon on Halloween, it's just a happy coincidence. And in fact, this will be a full moon on Halloween and also a mini full moon. As the moon goes around the Earth, if you have a full moon when it's at its closest point, called perigee, it's called a super full moon. We had one of those back in May, and it got a lot of attention. But if you have a full moon when the moon is at its furthest point from the Earth, then it's 3,000 miles further away than it is when it's at its closest, and it's a little bit smaller and a little bit dimmer than a regular full moon. So if you're out there on Halloween, check out the moon and see if you can tell if it's a little bit smaller and dimmer than your average full moon. Now also, it's going to be a blue moon, which just means the second full moon in 1 month. And if you have a full moon on Halloween, automatically it's a blue moon as well, because there's only 29 and a half days between full moons. So if a moon is full on the 31st, it was also full on the 1st or 2nd of October. So I never heard a great explanation for why they call it a blue moon. It doesn't change color. One theory I've heard is that it comes from the French word for double, which is double. So going from double to blue moon, to me, seems to be a good explanation for where that term comes from. So the Halloween full moon, first full moon in 19 years, last full moon to the mid-2030s, also a mini moon, also a blue moon. Lots going on that night in one little moon. So we're going to now go to the morning sky. A nice thing about observing the stars in the fall is that the winter stars are already on parade, even though we're still in the heart of the autumn. And so the stars of winter are brighter than the stars of fall. So it can be a real effort finding the bright stars of Perseus and so forth, but the winter stars we'll see in the morning sky pop right out. And speaking of popping out, as we go to just before dawn here, we're going to catch the planet Venus as well. Venus is blazingly bright, although Mars and Jupiter are neck and neck in terms of being about the same brightness, about minus 2.4 magnitude. At minus 4 mag, the planet Venus will always outshine every other planet in the sky. And it'll be with us also until the end of the year, coming up just before dawn, just below the constellation right now of Leo the Lion. We have the planet Venus covered in those bright, shiny clouds. It will be getting lower and lower every night as we head to the end of 2020, but it'll be there as a bright morning beacon all the way till the end of this year. So you got 3 planets that are going away right at the end of the year: Venus in the morning sky, Jupiter and Saturn in the evening sky. Now also high overhead, we can easily catch Orion the Hunter, the most striking of all the constellations in the sky. Easy to find, pops right out, can't miss it. Far brighter than the stars that make up the Big Dipper. Orion is facing off against Taurus the Bull, which has a bright star called Aldebaran. Riding on the back of the bull are the 7 sisters, the Pleiades, that Orion is pursuing, and the bull is there to help protect them. So those are just a few of the great sights you can see in the early morning sky if you're an early riser. Also, the brightest star in the sky is down below Orion, on the other side of Orion from the Pleiades. Sirius, the dog star, at minus 1.4 magnitude, outshines every other star, although it itself is outshone right now by Jupiter and Mars and Venus. All the really bright stars, in fact, in the winter constellations can be pulled together into a great circle in the sky. And that includes Sirius, the bright star, which is in Canis Major, the big dog; Procyon, the bright star in the little dog, Canis Minor; Castor and Pollux, the Gemini twins; Capella, the bright star in Auriga, the charioteer; and Orion the Hunter, and Aldebaran, the bright star in the bull. So quite the parade of lovely sights, and if you have even binoculars, you can also see a couple of other really interesting sights close up. The Pleiades, seen close up, they're often called the 7 sisters, but there's many, many more stars visible in binoculars or a telescope. And these are all stars born from a common gas cloud, and you can still see some of the gas left over from the formation of the Pleiades. Now, the Pleiades rising at sunset 2,000 years ago in Ireland marked off Samhain, the Irish Day of the Dead and New Year that evolved into Halloween. And over in Japan, they call these the Subaru, and they named the auto after it. If you have a Subaru, check out your logo. It is a portrait of these stars, the Pleiades, or the so-called Seven Sisters, although to the naked eye, only 6 are generally visible. Now, Orion has a nebula in its sword that gives you a good example of where the Pleiades came from. So the Orion Nebula, which is about 1,500 light years away, is this giant cloud of gas and dust in which stars are being born. It's a great star factory. And it's not going to be around for much longer, maybe 1 million years, which is nothing in terms of astronomy time, because all of these stars that form out of this cloud of gas, as fusion begins in their core and they light up their parent nebula, eventually all the gas will be blown away as the stars form from wind coming from those stars. And so in a couple million years, we'll have some bright baby stars and a few wisps of gas left over from the nebula they were formed from. In other words, in a few millions of years, the Orion Nebula will resemble the Pleiades. This imagery, by the way, is based on imagery from the Hubble Space Telescope and the Spitzer Infrared Telescope. These are 2 different space telescopes that NASA uses above our atmosphere to peer deep into our galaxy. And so they worked with Hollywood special effects to create the most vivid recreation ever made of the great Orion Nebula. So that is in the sword of Orion, and again, we're seeing it in the very brief window of a few million years where the Orion Nebula exists at all. While it does exist, it is the most active star factory that we have anywhere near planet Earth. You can see the Orion Nebula, by the way, even with a small telescope in your backyard. The 4 really bright stars in the middle, called the trapezium, are so bright they light up the gas around them. And you can see that very clearly, even in a small backyard telescope, for example. So we have all these constellations on parade in the morning sky, and we also have Venus again with us, really until the end of 2020. But it's going to come up later and later, and the window to catch it before daybreak will get smaller as we get towards December. Venus is bright because it's covered in shiny and very reflective clouds. It's also a good-sized planet, about the size of Earth, and is frequently the nearest planet to Earth. Ironically, what makes Venus beautiful, i.e. those shiny clouds, make it a no-good place because the clouds trap and the atmosphere trap heat on the surface like glass traps heat in a greenhouse. So down here on Venus, it's always 861 degrees Fahrenheit. The Soviets bravely landed 2 robots that lasted only about 2 hours before the heat and the pressure knocked them out. From a safer distance, the Magellan mission in the 90s was able to radar map the entire planet because normally we can't see through those clouds at all. But thanks to Magellan, we have really good maps of what all of Venus looks like. Most of Venus is a rolling plain, not unlike Iowa, if it was 860 all the time in Iowa, with a couple of major continents popping up. Or they would be continents if there was water, but of course you can't have water at a place where it's 860 Fahrenheit. Even lead would melt on the surface. While it lacks water, Venus does have volcanoes, maybe 100 at a time. We have confirmed recently the active volcanic lay of the land here on the planet Venus. But a very strange world, unbearably hot. The pressure is so thick it's like being a half a mile down in an ocean on Earth. We'll never have humans in the foreseeable future survive. And even landing a rover, a robot on Venus is a real challenge. As we saw, the Soviet mission lasted 117 minutes before the heat and the pressure conked it out. So Venus is in the morning sky now, low in the east, coming up before sunrise, and we'll have a chance to catch it right on the horizon before day breaks by the first of the year, and that will be it then. So that is the planet Venus. And the last thing I wanted to mention is to talk a little bit more about the planet Mars, because Mars is also a very intriguing world. And Mars, in fact, is a world that has a lot more in common with Earth than the planet Venus does. Even though Mars is small, it surprises folks how small Mars is. Half the size of Earth. If you weighed 100 pounds on Earth, you weigh just 38 pounds on Mars. And that has had a big impact on the fate of Mars, because with low gravity, Mars couldn't hold a thick atmosphere. And without a thick atmosphere, it couldn't hold water. And yet, despite that fact, there's a lot of things we have in common with Mars. Earth and Mars are both tilted dramatically, which causes seasons on both planets, whereas Venus is straight up, no seasons whatsoever. Also, unlike Venus, Mars has moons, although these are just captured asteroids. Phobos and Deimos, fear and terror, tie into the idea that Mars also stands for the god of war. Here we see a polar cap, and the caps actually do change with the seasons as well. That was a clue way back in the 17th century that Mars had active seasons. Mars has a very thin air, maybe 100 times as thin as the air on Earth, or 10,000 times as thin as air on Venus. But in that thin air, the Martian dust is so fine it's easily whipped up into little Martian dust devils, as you see here, or even planet-wide dust storms occasionally. But most of the time, the air is clear on Mars. It's really cold, about 100 degrees below 0 Fahrenheit, a good average Martian temperature. But that's not a whole lot worse than the temperature on Antarctica, and is much more survivable than the horrendous environment of the planet Venus. So when we send humans to the planets, we're going to go to Mars first. Now, another contrast between Mars and Venus is that Mars is geologically dead. It was very active once upon a time and created these enormous and now extinct volcanoes like Mount Olympus, which is about the size of New York State and about 13 miles high, so 2.5 times the height of Everest. And there's also giant canyons on Mars. The Valley of the Mariners is this great crack in the crust, but 4 times as deep as the Grand Canyon on Earth, and 3,000 miles long. We go all the way from Los Angeles to Jersey City here on Earth. But mainly signs of a past active geology on Mars, not a current geology. The gradual wearing down of the sands of Mars is the main geological thing, and the wind is the main shaping factor on the landscape of Mars now. But Mars was very different once upon a time. Once it was very active geologically, and once upon a time it clearly had lots of water. There's many lines of evidence from our robot probes and landers that water flowed across Mars in great amounts, billions of years ago. So once upon a time, it wasn't just a red planet. It was a red and blue planet. But with the thin air, Mars couldn't hold on to its water, and it evaporated and evolved into the current dusty planet that we know today. But we're very intrigued by this history of Mars for a number of reasons. Among other things, could life have gotten going back when Mars had water? Wherever we have water on Earth, for example, we have life. So that's a point behind the Perseverance mission that's landing on Mars in February 18. It's going to land. It's going to gather samples from the Martian soil and store them on board until another mission comes, maybe a decade down the road, and will collect those samples and bring them back to Earth to analyze in Earth laboratories. So we're intrigued. Could Mars have developed life back in ancient times? That's one of the big questions about the planet Mars. We haven't found evidence of life anywhere else in our solar system besides Earth so far, but Mars still remains a candidate, at least for prehistoric life. It raises the intriguing possibility. We know that bits of Mars have occasionally hit Earth. What if life got going on Mars billions of years ago? And what if an asteroid from Mars hit Earth and actually is how life came to Earth? That would, I guess, make all of us into being Martians. And whether or not there ever were Martians, whether we're Martians or not, there'll be Martians someday, because someday humans will live on Mars, and they'll consider Mars rather than the Earth to be their home. So Mars has got promise, and that's one reason why we study the planet so much, is that we do plan someday, maybe within the next 20 years, to have the first human mission going to the planet Mars. So that is our program. So lots going on. All those planets are there in the sky. Great lineup all the rest of 2020 for catching the planets in the sky. Only little Mercury is really pretty much lost in the sun. And also both the parade of the fall constellations and the brilliant constellations of winter there in the morning sky. So thanks again for having us, Montclair State University alumni, and your congratulations again on your homecoming event. And we hope to see you someday at our planetarium at Liberty Science Center. Thank you, everyone.